Okay, number one, domain is simply listing the x values. I'll do it in least to greatest order. So I've got a -2. Don't list it twice, even though it's there twice. And 3, that's my domain. For the range, list the y values, least to greatest, 1, 4, and 5. Then they asked us to determine if it's a function. The answer to that is no. And it's not a function because -2 got mapped to 1 and to 4. There was duplication there. Now number 2, determine if it's linear, first of all. So we can think of f of x as y equals 2/3 x minus 5. Yes, that's in slope-intercept form. It doesn't matter that 2/3 is a fraction. X is not in the denominator, so it is linear. Then we're also supposed to find f of 6. So you just plug 6 in place of x, so 2/3 times 6 minus 5, that's like 6 over 1. The 6 and the 3 can simplify because they're both divisible by 3. So I get 4 minus 5 is -1. So f of 6 is -1. Number 3, that one is not linear. It's not linear because of that x squared term in there. If the x squared term was gone and it was just x minus 2, that would be a different story. We can still go ahead and evaluate for f of -3. So plug -3 in, it gets squared, so I have to put the entire -3 in parentheses when I square it, so that it becomes positive. Plus a -3 minus 2, so -3 squared is 9. We can write that as -3 minus 2. 9 minus 3 is 6, minus 2 is 4. So f of f of -3 is equal to 4. Number 5, standard form. So we need to put the x and the y on the left side, move the 7 to the right side. I also want to make sure that I don't have fractions. Looks like I'm going to have to multiply both sides of the equation by 3, whether it's now or later, doesn't matter. But I'll just do it right now. So 15x plus 21 equals, over there the 1/3 times 3 will just be a 1, so I'll just get y. Then I'm going to subtract the y over, and I'll subtract the 21 over to the right side, giving me 15x minus y is equal to -21. That is standard form. Because the x term is positive, there's no fractions anymore. The y is over on the other side. Number 5, that 10's got to go to the other side. And then my x term needs to be positive, so I'm going to divide or multiply either way everything by a -1 to switch my sign, so I get x minus 2y equals positive 10. Now the a is positive, so there we go. Number 6, we're dealing with 2 colleges, so it's really 2 different problems. So let's focus on State College first. They tell us that in 2002 the population was 23,142. That's really an ordered pair. 2002 is the independent variable, 23,142 is the dependent variable. But then also at State College in 2010 we have a different population, so that's another ordered pair, where they had a population of 29,563. Well, we have a similar problem for Central University, but let's deal with State College first. So to find the rate at which they're growing, the average population increase per year, we would use the slope formula. You subtract the y values. It's the y2 minus y1, y2 minus y1 over x2 minus x1. That formula is what we're using here. So I would take 29,563 minus 23,142 over 2010 minus 2002. When I do that, that numerator, 29,563 minus 23,142 is 6,421. That would be over 8. Now we can leave it as a fraction, or we can go ahead and write it as a decimal. If you write it as a decimal, we get 802.625. That's how much we're going up a year. That's the population increase per year. So that's for State College. Let's go ahead and now look at Central University. Do the exact same thing. 2002, population was 34,689. In 2010, population was 36,107. So 36,107 minus 34,689 over 2010 minus 2002. So 36,107 minus 34,689 is 1,418. And when we divide that by 8, we get 177.25. That's how much their increase in their enrollment is increasing per year over that 8-year period on average. Okay, 7, 8, 9, we're graphing. 7's in slope-intercept form. If we remember slope-intercept form, we would remember that we should start with the y-intercept. The y-intercept is positive 1, so go to your y-axis to positive 1 and put a point there. And then our slope is negative 2. I'm going to think of that as a fraction because of rise over run, so negative 2 over 1. The 2 is negative, the 1 is positive. So we rise negative 2, we go down 2, and then we run a positive 1, so we go down 2, 1 to the right. Then you can continue doing that to get more and more points. You can go up 2, back 1 as well to get on the same graph. You connect the points for your line. Number 8's almost in standard form. I'm going to move that 18 over. Even though I could divide them both by everything by 3, I have a negative x value. I'm okay with stopping there for a moment, just so I can find my x and y intercept so I can graph this. To find the x, you could switch over to slope-intercept form if you want, but this one's a little easier. To find your x-intercept, plug in 0 for y. So we would have negative 6x equals 18. So we divide by negative 6, you get negative 3. Negative 3, 0 is your x-intercept. Oh, sorry, negative 3. And then for y-intercept, plug in 0 for x. So you get 3y equals 18, so y must be 6. So 0, 6. It goes off my graph a little bit. But then connect through those dots and you've got your line. Number 9 is also in standard form. So the x-intercept, plug in 0 for y. 2x equals 12, so we would get 6, 6, 0. For the y-intercept, plug in 0 for the x value. So you end up with negative 6y equals 12, so you would get negative 2. 6 zeros off there just a little bit. There's 0, negative 2. Oops. And there's our line for number 9. Then we'll go to the back page. We've got to be parallel. Oh, sorry, I'm looking at the wrong question. Number 10. We've got a slope and we've got a point, so I'm going to use point-slope form. You don't have to. But y minus 8 equals my slope, negative 2/3, times x minus negative 2. That would be x plus 2. Distribute. Negative 2/3 x minus 4/3. I'm going to add 8, which really I'd like a common denominator, so that's 24 over 3. It's the same thing as 8, but now I have a common denominator over there. So I get y equals negative 2/3 x, negative 4 and positive 24 makes positive 20, so plus 20/3. Number 11, slope is 0, which means it's a horizontal line. It's just a y equals equation. Y equals 0x. You know, ultimately we can just look at the y value here, 9. We get y equals 9. You can't do that if it's not a horizontal or vertical line, but it was in this case. Number 12, I can go back to my point-slope form. Y minus 5 is equal to my slope times x minus 4. Distribute. 2x minus 8. Add your 5. Y equals 2x minus 3. Now number 13, we've got parallel lines. Parallel to that equation, so we have the same slope, so we're using a slope of 5/2. Don't use that equation for anything else. You now have a point and a slope, so it's like the last problems. Y minus negative 3, so y plus 3 is equal to 5 halves times x minus 1. Distribute, y plus 3 equals 5 halves x minus 5 halves. Next I'm going to subtract 3. Or as to make a common denominator, I'm going to subtract 6 over 2. And so I get y equals 5 halves x. Negative 5, negative 6 makes negative 11, so negative 11 halves. Number 14, parallel, so we have a slope, same slope, slope of 5. Don't use the negative 8 for anything. Y minus 3 equals 5 times x minus negative 2, that's x plus 2. Distribute. Y minus 3 equals 5x plus 10. Add the 3, y equals 5x plus 13. Now with number 15, we're perpendicular, so we want opposite reciprocal slopes. So opposite reciprocal of 2 is negative 1/2. I'm done with that equation. Y minus negative 1, so y plus 1 is equal to negative 1/2 times x minus 4. Distribute, y plus 1 equals negative 1/2 x plus 2. Subtract your 1, y equals negative 1/2 x plus 1. Number 16, still perpendicular, so we do opposite reciprocal slope. Opposite reciprocal of negative 5 is positive 1/5. So y minus negative 2 equals 1/5 times x minus 6. That's y plus 2. So 1/5 x minus 6/5. Now I'm going to subtract 2, but I want a common denominator, so I'm going to subtract 10/5. Giving me y equals 1/5 x. Negative 6 and negative 10 make negative 16/5. Number 17, we've got 2 points. We've got to go through, got to find our slope. So y2 minus y1 over x2 minus x1. So negative 1 over negative 3. Negative over negative is positive 1/3. Notice this problem gives me the slope, or the y-intercept 0, 3 has a 0 in the x spot, so 3 is the b. So I can just do y equals 1/3 x plus 3. So I found my slope, I know the y-intercept. Number 18, we have to find the slope. 11 minus negative 4 over 10 minus 5. Minus a negative 4 is like plus 4, so 11 plus 4 is 15. 10 minus 5 is 5. 15 divided by 5 is 3. And then pick one of the two ordered pairs. I'm going to use 5, negative 4. So y minus negative 4 is equal to my slope, 3 times x minus 5. Y minus 4 is like y plus 4. Distribute the 3 to get 3x minus 15. Subtract 4, y equals 3x minus 19. Number 19. Rental car costs $50. It's a one-time fee. And then 20 cents per mile. Write an equation. So y equals, we got $50 up front, and then 20 cents, so 0.2 times every mile, so times x. There's my equation. And then determine the cost if we drive 225 miles. So we would just plug 225 in place of x, and we can evaluate this. So 50 plus 0.2 times 225, we get $95. Thanks for watching.